Welcome back. I hope you're all finding success on multiplying fractions by fractions using the visual model of a unit square and finding the product that way. Today we're going to explore how to multiply fractions by fractions symbolically, or what we typically would call as using the algorithm. So let's start with a review on what we had talked about the other day. So when we are multiplying fractions by another fraction, we're thinking of taking a unit square and breaking that unit into pieces to find our product. So it was always less than what we started with because we were taking a piece of one whole. So when we had 1/2 and we were finding what 1/3 of 1/2 is, our answer was naturally going to be less than 1/2 because we were taking 1/3 of a half. So things to just keep in mind: making sure that your answer is logical. So in these examples of just common fractions multiplied by other common fractions, you should always have an answer that's less than what you started with because you are taking a piece out of a piece. All right, so why don't we take a moment and show kind of what you know on 2/3 times 5/6. Okay, so why don't we think about some patterns you may have noticed when you were doing your practice sheets yesterday. So here's an example. David was thinking about multiplying 1/2 times 1/5 and noticed something interesting. 1/2 times 1/5 equaled 1/10. So what do you think he noticed about the numerators and the denominators? And if you kind of look at the color coding that I used, 1 times 1 for our numerators equaled 1 in our final product for our numerator. 2 times 5 in our denominator ended up equaling 10, which was our final product for the denominator. He decided that maybe he would try the same thinking out with another problem to make sure he was on the right track. So he tried it with 1/2 times 6/8. Again, you'll notice the color coding. 1 times 6 equals 6, and then 2 times 8 equals 16. We have our matching visuals on the right-hand side that show our 1/2 times our 1/5, and what would be double shaded would be that 1/10. And then we also can show the same thing with 1/2 times 6/8 and 6/16 being shaded in twice. So something to really be thinking about. Hopefully you're making a connection right now. Yes, hopefully you noticed that you can just set your two fractions up next to each other and multiply straight across. So to find the product of two fractions, you're going to multiply the numerators and then multiply the denominators. The two products form the fraction, which gives you your overall product of an answer. So here's the nice example: 5/2 times 11/10, 5 times 11, and 2 times 10. You'll get 55/20, which we could then, of course, reduce if we so chose. So hopefully you were able to notice that pattern as well. You're just multiplying straight across. And that is our algorithm. So step 1, multiply your numerators together. Step 2, multiply your denominators together. Step 3, simplify if need be. It is as easy as that. A little bit easier, a lot easier actually, than adding or subtracting fractions. You do not need a common denominator. You are just multiplying the numerators and then multiplying the denominators. And we've proven why that works in our visual models. So why don't we try a couple more? I also want you to take a moment to think about what if you had a whole number. So what if it wasn't a fraction by a fraction, but it was a whole number by a fraction, which is exactly what we were doing last week and 2 weeks ago. And we were thinking about multiplying our whole number by our numerator and keeping our denominator the same. So how does that work using the same algorithm we were just talking about? Hopefully you're starting to think about the fact that you know 3 wholes is also equal to 3/1, 3 whole groups. So we can make that a fraction. And 3 times 3/4 could actually look something like this: 3/1 times 3/4. So hopefully you're thinking about now you could just use that algorithm again and you would get 9/4, which goes exactly with what we had talked about last week on multiplying whole numbers and fractions. We were really doing the same process. We just weren't really thinking about it in terms of the algorithm. So you're going to be taking a few moments after to kind of do a few more. Let us know how you're feeling about multiplying using the algorithm, and hopefully you find success in your practice this week. Hopefully you find some success, and thank you for joining us, and we look forward to seeing you again soon.